So in this step we're going to mount the separator LEDs, and to do that we're going to use an MPSA 42, that's Q6, a 1K resistor, that's slightly magnetic, which has the color code brown, black, red, and I'm going to use the two LEDs that came in the kit package. So Q6 goes here, and the resistor R37 goes next to it. And what we're going to have to do is we're going to have to select whether we want to use LEDs or if we use neons. And we're going to use LEDs, and to that we have to connect here on this header V in and common. If we were doing the neons, we would connect 170 volts to common. But because we're doing the LEDs, these two, we're going to bridge them over just with a bit of leftover connecting wire. Okay, so let's get on. So first of all, the MPSA 42, let's bend the middle lead back like we did with the 2N7000s, and we'll put it in so that it sits at about the same height as the field effect transistors. Need to grab my solder, and we will trim up the two leads which we just soldered to make it easy to get into the third lead. The MPSA 42 is kind of bulletproof. These are really good old-fashioned, super tough junction transistors. Don't need to be very careful with them. They can handle everything. So, and the resistor R37 goes in next to it. And I just bent one lead to keep it in place. Let's have a look. Okay, that's fine. Now the choice of R38 and R39 depends on whether we're using the LEDs or the neons for this. And for the LEDs we can use the two 1K resistors that came in the kit. And R38 is here and R39 is here. So we will mount these guys the same as the others in their group. So R38 goes in. So make a bit of space for it in that space there. Now I'm not actually going to mount the LEDs at the moment because I want to see how they fit up against the tubes. So until we've mounted the tubes, it's hard to really estimate the height that the LEDs should go at. I'll give you an idea of what that means in a moment. When we come to mounting the tubes, you'll see that they sit up kind of at this level. So they sit up sort of like that. Now, we want the LED to be somewhere in the middle of the tube, right? Normally this means that it's about 38 millimeters of lead above the board. So if we were to measure 38 millimeters up there, that gets us the LED into the middle of where the tube will be. But we'll do that as a later step. The last thing we should remember to do in this step is take an offcut of a component lead that you had from before, form it into a U, and we will actually join up the common and the V-in. So the LEDs require to be driven from V-in rather. And if we were using neons, it would need the 170 volt. You also need different resistors if you're doing the neons. The reason we don't have a header for this is it's a kind of fit and forget option, this one. If you need to change from LEDs to neons, you have to change the neons and the resistors and all of the rest of it. Now if you can see just there, we've got a bridge between these two. So that's this step finished, apart from the LEDs, which we will mount at the very, very end. Next comes the front panel components. And the front panel component is SV2 here. Some people prefer to mount this on top, the header. Some people prefer to mount it on the bottom. I think if you put it on the top, it's ugly because it obscures the view to the tube, so I prefer to put it on the bottom of the board like this. It leaves enough room when the Arduino is on there so that there's plenty of room to connect the wires. So if I can get this in here, you see if the header is on the bottom, it's not fouling anything. So to do this, we'll just tape our connector, our header in, and we'll solder one pin, and that's gone in not completely straight, so we'll straighten it up. Now it's straight, and we can solder the other leads. That's this step done. I've got a switch and an LDR on a connector here, but you will have to wire this up so it fits the case that you're using. So you may also choose not to install the header and just have wires coming directly from the board. Just one thing to say about this. The ground pin is on the far right here, and that is the common pin for both the switch and the LDR. So the switch is this pin, and to activate it you pull it to ground, and the LDR is this pin, and it also is measured to ground. The VCC pin is not used on this connector. So I'm going to show you the process now for mounting one of the tubes. These are actually pretty tricky to mount, and I find a particularly good trick is that we'll straighten out the pins on the tube, and then we'll trim them to go around in a spiral. Trying to get equal length tubes in these sockets is pretty tricky. So I find it quite useful to actually trim them round in a kind of a spiral, starting kind of at the anode, and then you trim up like this, leaving enough for the last tube so that you have enough room to solder it. So it shouldn't be shorter than this. So measure it against how it will be in the board and say, okay, well, this is my minimum length. You can also trim, if you want to be sure, trim back outwards. So let's actually trim these guys up. So rather than just talking about it, let's do it. So my minimum length is here. I give myself some room for error, and I'll actually start trimming the leads in a spiral, like I mentioned. So they're all different lengths. And now we can actually start to thread these guys in. And of course, the anode is the one at the back here. So it's really fiddly, this. You will notice that it can drive you kind of crazy. But trimming in a spiral really does help. I'm not sure if the camera can stay in focus while I poke these guys into their holes. But basically, if you've trimmed them into spiral, you can put one lead in at a time, more or less. You may need to help a couple of leads in with a guide, or I've got two there that ended up kind of the same, but never mind. We're getting there. Okay, look, so there we go. Let's tweak it a bit so that it's facing forwards. And what we're going to do is we're actually going to just solder 3 points on these, because that means we can easily adjust the tube to stand upright. So look, I'm going to solder one here, one here, and the anode at the back. And this allows us then to adjust the tube just by loosening the connection on one of these at each time. So look, I loosen that one and he goes up. I loosen the anode and I can move him backwards and forwards. And I loosen this one just by applying a bit of heat. So I can now sit the tube down until he's sitting right above the LED. And it allows me some amount of flexibility. So if you can see, this guy's sitting too far forwards. So let's loosen up the anode at the back and we can make him stand more upright. So this is starting to look better. Don't force the tubes too much. They're quite sensitive. I mean, they're relatively robust, but I mean, if you force them, you always run the risk of causing them some damage. I'm nearly happy with that. I'd like to just no, I think we're good. I think it's still a little bit like this. I'm going to just loosen this guy at the front here. So it's important to put the tubes in one at a time. You should make sure that each tube is standing upright as you go along. So you can use something to measure that it's upright visually and front and back. I'm just using something which I know is a right angle and measuring it against the tube, and I know this tube is now okay. So I can solder this tube in and then we can test it. It's important to test between each tube that you solder in. If you solder them all in at once and a tube has an error or a problem, so there's a short internally to the tube, you won't know which one is the tube which has the error. So I'm going to finish now soldering this guy in, and we'll give the tube a test once it's all soldered in. So you should find the rest of the tubes are the rest of the leads are pretty easy to solder in. They don't take much effort. And now I'm going to do a preliminary trim. So I'm not going to trim them really short yet, just in case. Make sure that nothing is touching, that there are no shorts here, and then we can go for a test. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3. That looks good to me. So the next story is actually to fit all of the rest of the tubes in the same manner, but do a test after you fit each tube. The last thing I'm going to do is just finally trim up these leads now that we know that the tube is all good. One other point, don't worry if not all of the leads on the tube are actually, you can see here actually one of them has been trimmed off short. These tubes often have one of the decimal point leads trimmed off. It was, I don't know why they did it, but if you notice the IN14 has 2 decimal points, and one of them, I think it's the left hand one, they generally trim off on the tubes. If you really want it, you can extend the lead and use it again, but don't worry if you see it trimmed off.